In exercise 803, we look at the graph of simple interest. Now, as it says here, the simple interest graph is a linear function. So we've got to go back to thinking about our algebra and in particular the graphs. Now, we know that in algebra, if we have, I'll just change that, y is equal to mx plus b, then it graphs to give us a straight line. And obviously, when we graph that, our y is on the vertical axis and our x is on the horizontal axis. I'm now going to make that connection between the algebra and our formula for simple interest. Y is equal to, I'm going to write them smallish, P, R, and the N quite big, because this is similar in that the I is similar to the Y, the N is similar to the X. This PR ends up being our gradient. Those two numbers multiplied together is the equivalent of our gradient. And we have in this case that B is 0. B being 0, it means that our graph cuts the vertical axis at 0. And yes, you can see it does that here. So this is our 0. We've got a nice straight line. Its gradient is this PR, P times R. And N is the periods, and they're the things like X that change. Let's have a look at this example. Rachel invests $20,000 into an account that earns 6% per annum simple interest. A. Construct a graph that shows the simple interest earned in dollars for n years for values of n from 0 to 8. Now, hopefully you've read that and you can see construct a graph, and you know that to construct a graph, you're normally given an equation to work with. So you'd be saying, oh, they haven't given me an equation. But it's possible to form our own equation because we know about, we have a formula for I and a formula, an equation, similar things. So we need to start off with I equals P R N and form an equation that we can use. So we need the value for P, which we're given as 20,000, and our value for R, remember, it has to be a decimal, so it'll be 0.06 and N. Now, we'll do the calculation. And simplifying that, you get I is equal to 1,200 N. Now, this is what we're going to use to draw up what do we usually have next after an equation. We have a table of values. So we'll have our table of values where this time it will be N and I. And we're told our values of N have to go from 0 to 8. Now, when we get to choose the values that go in the table, we know that we only really need 3. So we could choose 0, 4 and 8 and go about calculating I for each one of those and add them to the table. I'll pause the video and do that. So you can see now that I've completed the table. When N is 0, I is 0. Now to get all of these values in the table, I used the formula that I created. So when N is 0, I is 0, and that then gives us a 0-0 pair to plot, 0, 0. Then when N is 4, we've got that I is 1,200 times 4, which is 4,800. So then I've got 4 and 4,800. It's another point to plot. And the last one is when N is 8, and that gives us the point 8 and 9600. So over here I've drawn my graph where this is my n value, just like I said, n replaces x, and this is my interest axis, and it's going up by 2,400, so I get to 9,600 as determined by this value here. And I draw my nice straight line. So I've constructed a graph. B asks, what does the gradient of this graph represent? Now, this is not where you give the value of the gradient. The value of the gradient is 1200, but what does it represent in this case? In this case, the 1200 represents, or the gradient represents the interest earned per year. The interest, because these are years, and this is the interest in dollars. C says use the graph to estimate 1. The amount of simple interest earned after 4.5 years. I'm going to attempt to dot a line, 4.5, so 5's come back a bit. Whoops, coming up to the graph and across here. Whoops, it's very hard for me. I suggest you use a ruler. So 4,800, maybe about 550 or approximately. Yeah, it's less than halfway between. So yes, I've estimated it to be about 5,500. You can work out where exactly halfway between these two values, exactly halfway between 4,800 and 7,200, and then come back even just a halfway again. So that's my estimation. We could use our formula to find it exactly, but the graph says estimate, and then in part 2 we have to estimate when, so that's the time, 8,000 in interest will be earned. So 8,000 is just a little bit after 7,200, so we come across to the graph and we come down. Now we might estimate that to be approximately 6.5 years. And of course, if you want more exact values, then you use the formula. So that completes the notes and the example, and you can write up your summary and key points and then do 803.